Find the tangential and normal components of acceleration, and then along the way find everything else that precedes that. Let's take number 21. So we find r prime of t. So we get I. This is t to the negative 1, so this becomes negative 1 over t squared j. We find then its norm. So we get the square root of 1 plus 1 over t to the 4th. You can simplify that. We can just write that as the square root of t to the 4th plus 1 divided by t squared. So the tangent vector is r prime divided by its norm, so we get t squared over the square root of 1 plus t to the 4th I minus t squared divided by t squared cancels out. This is 1 over the square root of 1 plus t to the 4th j. Let's see if we can use our theory to see if we can figure out the normal vector without having to go through the steps. But then I'll still find the normal vector as well. Look at the path x is equal to t, y is equal to 1 over t. So if x is equal to t, this implies that y is equal to 1 over x. So we got an asymptotic function, and then at t equal to 1, get 1 and 1. So say we're there. Let's find the direction. T cannot be 0. Start at 1. 1 for t, x is 1, and then y would be 1. Then say 2 for t and 2 for x, and we get 1/2. So let's see. So when x is 1, y is 1 right there, and then when x is 2, we get 1/2. So we're moving in this direction here. So in moving in that direction, that tells us that the tangent vector is also moving in that direction at that particular point. And so the normal vector is doing that. Okay. Interesting. So notice there that the normal vector for the tangent vector, notice here that x is moving in the positive direction, but it's going down, so y is negative. That matches. X positive, y negative. For the normal vector, x is positive, y is positive. So we make the stipulation that the normal vector is going to be 1 over the square root of 1 plus t to the 4th I plus t squared over the square root of 1 plus t to the 4th j. We'll check that. So t dot with n t squared over 1 plus t to the 4th minus t squared over 1 plus t to the 4th is equal to 0. So now I'll go through and do the work just to verify and make sure that that is the case, because sometimes you know how man's theories are. We theorize a lot of stuff and we get in trouble with it. So let's go back here, the tangent vector, let's change that color. So we get this t squared over the square root of 1 plus t to the 4th I minus 1 plus t to the 4th to the negative 1/2 j. And that is a 4 in there. So t prime of t, use the quotient rule, so we get 2t times the square root of 1 plus t to the 4th minus t squared times the derivative of the denominator, so that's a 1/2 times 1 plus t to the 4th to the negative 1/2 times 4t to the 3rd all over our denominator squared, 1 plus t to the 4th. This is all I. And then take the derivative of the jth position, so this is plus 1/2 times 1 plus t to the 4th. And this is negative 1/2 minus 1, so we get negative 3/2. Times the derivative of the inside, 4t to the 3rd, all times j. Let's clean that up. So t prime of t so this is 2t, the square root of 1 plus t to the 4th minus 4 times 1/2 is 2 t to the 5th. So this is 2 t to the 5th all over the square root 1 plus t to the 4th. And that's divided by 1 plus t to the 4th I. Plus we clean this up, we get 4 divided by 2 is 2 times t to the 3rd, and that's all over 1 plus t to the 4th to the 3/2 j. Now We'll clean that up. This is t prime. And we're going to add these two fractions. We're going to multiply this denominator to this denominator. And you multiply this term also in the numerator. So we get 2t times 1 plus t to the 4th minus 2t to the 5th. That's all over. The square root times the whole term is 1 plus t to the 4th to the 3/2 power. I plus 2t to the 3rd all over 1 plus t to the 4th to the 3/2 power. J. Now notice that 2t times t to the 4th would be 2t to the 5th, so the opposite, so those terms will cancel out. And so t prime, we can write, finally, it's just 2t all over 1 plus t to the 4th to 3/2 power I plus 2t to the 3rd all over 1 plus t to the 4th, the 3/2 power j. Find its norm. Find the normal vector. It's t prime divided by the norm of t prime. And I was correct. Find its norm. Find the norm of t prime, excuse me. So the norm of t prime, can I just write it like that? Is the square root 2t squared is 4t squared, and 2t to the 3rd squared is 4t. 3 raised to a power of 2 is 3 times 2 is 6, divided by this common term 1 plus t to the 4th, the 3/2 power. You can factor out a 4. The square root of 4 is 2. You can factor out t squared. The square root of t squared is t. You have left 1 plus t to the 4th. All over, look at that. This is 1 plus t to the 4th times the square root of 1 plus t to the 4th. So the norm of t prime is simply 2t all over 1 plus t to the 4th. So now we found that normal vector. It's t prime, there it is, divided by this norm of t prime. So we got 2t over the square, the cube root, 2t, excuse me, over 1 plus t to the 4th to the 3/2 power, divided by this 2t all over 1 plus t to the 4th. You see that the 2t's will cancel out. 1 plus t to the 4th will go to the numerator, divided by 1 plus t to the 4th to 3/2 power. You have left 1 over the square root of 1 plus t to the 4th. Plus, move over here. 2t to the 3rd divided by 2t is just t to the 2nd. And so 1 plus t to the 4th goes to the numerator, divided by 1 plus t to the 4th to the 3/2 power. And so all you have left would be the square root 1 plus t to the 4th j. Is that what we had surmised? That's it. That's it, right? That's what we got. All that work and we knew already. Okay. Now, to get the tangential component of acceleration and the normal component of acceleration, we need to find the acceleration. So A of t is r double prime of t. So r prime was this, I minus 1 over t squared j. Better write that over here. I minus t to the negative 2 j. So r double prime would be, that's a negative. This is positive 2 positive 2 times t to the negative 3 j. So taking the dot product, for the dot product with this acceleration and the tangent vector and the normal vector, the only components that contribute to that would be the jth component. Right? Let me just go ahead and just find a sub n, since I have n right here and I'm looking right at it. So a sub n is the dot product of a and n. So it's just going to be 2 over t to the third times t to the second all over the square root of 1 plus t to the fourth. So we clean that up. So this is 2 over t times the square root of 1 plus t to the fourth. And we'll find the numbers. Let's just go ahead and just find the hard terms. So a sub t, the tangential component of acceleration, is the dot product of a and t. So this is, again, 2 over t to the third times the jth component for the tangent. Here's the tangent right here. So it's just that negative 1 over the square root. So that just gives us negative 2 over t to the third times the square root of 1 plus t to the fourth. So now we need to get the little value for t. T is equal to 1. Thank goodness for that. So if t is equal to, little t is equal to 1, so that means that a sub t is equal to negative 2 over the square root of 2. A sub n would be 2 over the square root of 2. And I think we need to find I think it said find the tangent at 1 as well. So the tangent at 1 would be 1 over the square root of 2 minus 1 over the square root of 2. And the normal vector at 1 is just 1 over the square root of 2 I plus 1 over the square root of 2 j. That's the second thing. And then number 3, we have to find this one. And then number 4, find that. And I believe those were the 4 things that the question asked for. T of t, n of t, a sub t, and a sub n. Yes. Now, let me do one more. Number 28. But we're finding the same thing, but this problem's a lot easier. So r prime of t is negative, take the chain rule, so 4 times 3 is 12, and then the derivative of cosine is negative. Cosine 3t I plus 12 cosine 3t j. We find its norm, it's just 12. And so t of t is equal to r prime divided by 12, so that's just negative cosine 3ti sorry, this is the sine. The derivative of cosine is sine. Thank you for catching that. I heard you through the computer. You were saying it's supposed to be sine. Okay, I got it. I get it. All right, okay. Thank you. You're telling me again. See, I can hear through technology. No, I'm just joking. So this is negative sine 3t plus cosine 3tj. T prime of t is negative cosine, negative 3, excuse me, times cosine of 3ti minus 3 sine 3tj. The norm of t prime just give us 3. So the normal vector is just the tangent derivative divided by 3. So we get negative cosine 3ti minus sine 3tj. Okay, and so if that be the case, we need to find the acceleration. This is going to be r double prime of t. So take the second derivative, so we get negative 36 cosine 3ti, and then minus 36 sine 3tj. So a of pi, the acceleration evaluated at pi, right? We just find everything at pi. So cosine of pi, well, this becomes 3 times pi. So cosine of 3 pi would be negative 1. So this is positive 36. And then the sine of 3 pi is 0. So that's all we have for the acceleration. So the tangent evaluated at pi, well, the sine of 3 pi is 0. So all we have here for j is the cosine at 3 pi. So it's going to be a negative 1. So we get just negative j. And then for the normal vector at pi, so we plug in t to equal to pi, so we get cosine of 3 pi is -1 times a negative, we get just -I. And then we evaluate the sine at pi, that gives us 0. So a sub t is the dot product of a and t, and so the acceleration was 36I, and then the tangent evaluated at pi is -j, so we get 0 there. And then a sub n is a dot n. The acceleration is 36I. This is times the normal, which is -I. So here we just get -36. So that's the tangential component of acceleration, and this was the centripetal force of acceleration. And then the tangent vector, and then the normal vector. The normal vector, let me go back and look at that. The normal vector at pi, we plug in, we get 3 pi. It's negative times a negative is positive. Yeah, it's a positive. Don't want to give you anything that's incorrect. This is positive, and that's positive. That's better. I think that'll do it. Hopefully I won't make any more blunders. Well, I'm human. Okay. Thank you.